Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now in this tutorial, since in this tutorial we will be looking at how to make contour plots in Python. Now the last time we saw how to read data from netcdf files, and we'll be continuing that today. Okay, so what I'm going to do is that I'm just going to create it's okay, I think it's not needed. So what I'm going to do is that I'm going to show you guys how to make contour plots available in Python. So these are 2D plots, but let's see how it is. Now for that we need the same we can use the same matplotlib library for the same to do them as well. Okay, and contour plot comes in two varieties. One is called as contour f, other one is contour. So what's the difference? So let's type it out. Okay, now for instance for instance okay, now if I just type contour, we just type contour f of like this, I'll explain what's going on. See, now I'm taking longitude on the remember this remember this one, reading netcdf files. Now I read the netcdf file data. I read the netcdf file data and I have all the values in the memory right now, on the memory of the console right now. Okay, so what I'm going to do, I'm going to do a two-dimensional plotting. So what for that, I'm plotting the longitude. I'm keeping the longitude on the x-axis and the latitude on the x-axis, y-axis. Okay, that's a okay, longitude on x-axis and latitude on y-axis. And u is actually a three-dimensional array, so I cannot plot a three-dimensional array. So what I do is that I use the slicing operations and operations such that I just include only two-dimensional array. So if I just use u to be if I set u of phi, what it means is that it will just takes only the first, all the rows and columns away, all the columns and levels values of in first row alone. Now the colon indicates that we are taking all the full range. Okay, now u of phi colon make sure that you will be getting only the fifth row. You'll be slicing only the fifth row of this entire 3D matrix, and that slice of that fifth row will be actually a 2D slice, which is nothing but which will have all the columns and levels as a 2D value, set of value. So this will this will plot it. It will give a counter plot of that, and then plt.color bar is used for giving a color bar representation nearby. Okay, now remember I've done this entire thing is done such that I have the plot to be in Qt. I set matplotlib to be Qt so that the file gets posted on the screen. Okay, if I press enter, there you have it. The contour plot looks like this. Contour f plot looks like this. So if you guys look at this, if you guys just even zoom it up and look at this, the colors are okay. Yeah, the color features are okay. Okay, but it's not that pretty, to be honest. It's not that pretty. It has assumed its own color ranges, and it's kind of not pretty. It's good, but it's not that good. Okay, not bad. At least you can say it's okay, reasonably. Now if you guys look at it, the plot is okay. Now let me look at now let me just plot the contour, just the contour function. Just give you the contour plot. Okay, now if I were to run this, check this out. Now this does the same operation as above, but only thing is, instead of getting all the values, loops and everything filled, it just plots only the boundaries. Now this again is okay, but it's not that pretty. It's not at all pretty. In the sense, it's not that it doesn't look fancy or neat to us. So if you guys look at it, both the plots have the only thing, the difference between this is that contour has all the values just marked, whereas contour f has all the values colored. But if you notice something in both of them are not pretty separately, but there is a feature. But there is a feature to make it to enhance the plots in both of them. You can use both of these values simultaneously and enhance the features. How? Let's see. Let's use the best of both the features, best features of both the commands to get it done. for that, what I'm going to do, it's going to be a long file over here, so let me just do it one by one. First I need to import matplotlib. Okay, I'll explain you guys why I import this. Okay, I import matplotlib. Okay, second, what I do is that let me create a variable called as us, which is like this. I'll tell what it means. us is it's just a variable. It's not it's just a variable which is linearly spaced between minus 20 and 20, with 11 points between minus 20 and 20. This endpoint equals true ensures that while doing all this linear spacing, us has values both the starting point and end point are maintained. So if I look at this us over here, it has linearly spaced points between minus 20 and 20, and there are like total 11 points, including the starting and ending. Fine. Now that's us. Okay. Second, what you're going to do is that let's plot the contour. We use the same contour. We use the longitude, latitude, and then we'll plot we'll plot the east-west velocity at time phi, keeping all the longitude and latitudes as it is, with us being plugged into it. Okay, and with CMAP to be seismic. Now let me explain what's going on. See, if I do not if I just plot what do I do with it? Lat u of 5 colon, if you just print enter, okay, you will get the plot like this. Okay, you will get the plot like this. Now the thing is, if I do the same with us along with it, now what this does is that it will just divide the color scheming as per the ranges, as per the spacing given by us. Okay, if you go look at this plot, press enter, now the colors are much broken down. Okay, now the groups or contour groups are broken into smaller fractions because of us, based on the values I've given in us. So what I do is that this is okay. If I put CMAP equals seismic, okay, if I press enter, what it does is that it changes the color map. Now seismic is actually the conventional blue, white, red scheming, wherein wherever you have blue, it means the values are negative. Wherever you have red, they are positive. Wherever you have white, they are close to zero. Okay, now if I look at plt dot color bar, as of now, let me type color bar to it. This is how the values look like. This is how the ranges looks like. Okay, not bad. As of now, it looks okay. Now, so what I'm going to do is that I'm going to run this. Keep the plot as it is. Okay, there are a few more enhancements you have to do. Color plot is done. Okay, similarly you have other options as well. Now if you look at this command, I commented this out. Okay, commented this out, but this can also be done. If you include like 40 over here, what it does is that it divides the contour regions into 40. It just makes the contour distribution as 40. Here us is used for defining the contour ranges, whereas here it will take the maximum minimum values in the plot and divides the entire range into 40 ranges or 40 levels over here, or 40 contours, 40 groups like that. And then line width equals 3 makes sure that the lines that separate the contour to be 3 pixels thick, 3 units thick. Okay, and then CMAP just underscore heat underscore R is another color map. That's it. It's just a single color scheme. And then Vmin equals 0. Vmin and Vmax are used for setting the maximum minimum values to be contoured in the contour program. Contour function. Okay, that's about that. Vmin actually sets the minimum value to be contoured. Any value below Vmin and Vmin is treated to have the same color, whereas Vmax sets the maximum value to be contoured. Any value which is Vmax and above Vmax will be having the same color. Okay, that's one option. Now if you look at the plot, it looks okay as of now. Let's make it a little more fancy. Now let's plot the x label and y label just like how we did in the last time. Okay, stupid. Okay, fine. Let me plot this as well. X label, y label, and text. Okay, let me copy these and paste it over here. Okay, x label gets the label of x-axis, and then y-axis is given by y label. Font size equal 10. Make sure that the font size is increased for the contents. And next text, make sure that the values, the x-axis is broken into multiple places using the array given over here. What this array does is that it gives numbers between 0 and 360 in steps of 30. So we'll have numbers like such as 0, 30, 60, 90, 120, 150, 180, and so on till 300, till the last but one value of 360. So if I press enter, you have all the x text made and the axis being nicely made. So if you look at it, okay, the x label is here, y label is here, and the x axis is broken down at equal intervals. Fine. And now let's look, the explanations are given here, and then what I'm going to do, let me plot the y text as well. Now the y-text is actually between minus 90 to 100, but in steps of 15. So you look at minus 90, minus 75, minus 60, so on up till 90. So if I press enter, you have all the y-text ready in the y-axis, and check this out. Your y-axis is split into multiple places. Not bad. Not bad. Now let's make this plot a little more enhancing. So what we do is that we have the text ready. Add the title and super titles, copy that and paste it over here. Okay, paste it over here, and then let's look at the plot. Super title and normal title are ready, fair enough. And then let's look at this. Titles are ready. Now let's put the grid and axis. Let's switch the grid axis on and grid axis on and plot axis and normal axis on. Okay, let me copy that. This opens the grids, and this makes the axis to be steady. We plot that. Check it out. The axes are set, the y-axis set, x-axis set between 0 to 360, y-axis set between minus 90 to 90. Okay, and if you zoom in, you have the grid lines ready. Okay, let this be as it is. Okay, now let's make a few things. Now let's break the color bar. Now for the color bar, okay, plt.colorbar is sufficient to make the color bar, but tix equals us, the value us we used over here, we pass the same thing over here. What this does is that it makes sure that the color bar is split with the same color ranges that corresponds to the color ranges used in contour function. Okay, so if I copy this and paste it over here and press enter. Okay, now if you look at the figure, check it out, we have a color bar ready along with it. Okay, now we have included all the extra accessory features for the plot, and the plot is now readable and it's easy to follow, but the plot quality is it's not that striking. Okay, now let's do something about that. Okay, now remember I told you guys in the beginning that I imported matplotlib. There's a reason for it. Now what I'm going to do is I'm going to set a parameter in matplotlib module which is called as rcparams, to have a different value. Now what I'm going to do is that in this line there's a matplotlib has a dictionary called as rcparams. In that there is a key called as contour.negative underscore line style. I'm going to set this to be solid. Okay, now if I don't do that, okay, now I'll tell you why. If I were to plot this line, okay, copy this and watch this figure. It's okay. Now what I do is that if I just plot this line, check this out. Let me zoom this up. Wherever you have negative values, the negative values are plotted with dashed lines, and wherever you have positive values, you have them plotted with solid lines. Okay, that is because by the default, that is due to the default settings available in it's because of the default settings available in the matplotlib for contour function. What I'm actually done is that on top of this contour f, I'm plotting the contour function. So this, to make sure that the lines become a little more thick. Okay, so what I've done here is that I plot the same function with the same values, but the colors to be k, meaning all the lines should have a single color called as k. Here k is used for making it black. Okay, now what I do instead, if I set this lines to, if I copy this line and paste it, meaning if I set this parameter matplotlib.rc params color dot contour dot negative underscore line style to be solid, okay, and repeat the command on the top, check this out. Now all the dashed lines we got over there on the backs in the previous line, they become solids, and the plot now, if you zoom it up, it looks neat. It looks nice, isn't it? It looks nice. Then what I'm going to do is that now this makes the plot complete. You have a title, super title, latitude, longitude, axis, grids, corresponding color bar to the lines and everything, and it's very readable. If you have this shade of blue, it means that this shade of blue velocities are between -4 and -8 meter per second, like that, and all of these are set nicely. Okay, that's about. Now let me not close this. And now what you can do is that you can save this figure. Now what I do is that for saving this figure, you can go about with an option like this, something like this. Plot save fig, same figure, the same line that we used last time, do it, but this I will not at all recommend, because if you see, it's taking so much time. And if you see this option over here, it's saying that the console is running. So if I were to go to the data sets, you see this png file over here. If you just look at the bottom below, immediately below, on the top, on your bottom right part of the screen, you say that the file is being generated. tvsz4.png is getting generated, and finally it is like 10.6 MB long, 10.6 no 11 MB long, 11 MB big. And if I open this, it's going to be very memory consuming, and your image viewer or file viewer, it's going to have a tough time opening this. You may get something like this, but it's because the value is so big, it's a little hard. So what can be done is that if you're using contour plots and everything, this may be too much. Okay, so if you look at an alternative, let us cut the DPI to be shorter, DPI to be small, and then the bigger picture comes in, and you look at the coloring, it's okay. With 200 DPI, it looks good. But the colors, if you see, the colors look a little tarnished. The overall lines look fine, but the colors look a little tarnished. So what can be done? Let me save the file with a higher DPI, something like 400 DPI. I press enter. It is taking time, but when I look at the plot, it has improved a bit, but the color is still tarnished. It's not that good. Color is still not good. Okay, so in this kind of situation, the one best option to do is that go with another file format called as EPS, encapsulated PostScript. So what happens is that when you save the file to PNG and everything, sometimes the color gets leached out. As a result, you may find that the plots to be little not so good. The colors of the plots to be not so good. So what I'm going to do is I'm going to save the file in this format called as EPS. Okay, Let me copy this up, paste it over here, and voila. If you look at the EPS file, it's getting generated. It's 1.8 MB in size, but still, if you look at the file, it's good. The colors are retained and the plots are good. Okay, you might find this a little bit too messy because of the kind of ranges we used over here, but still the plot looks good. And the good thing about this is the sizes of the EPS files are much smaller. The PNG file we generated over here is the PNG file we generated in the previously was big, but this is smaller. Okay, and the color quality, color is also not etched like we saw over here. The colors are also conserved without any problem. And we can set this to last time what we did is that we set save the figure to have 200 dpi. Let's set this to 2000 dpi. Let's see how it looks like. I think you won't notice much of a change. I think you won't notice much of a change because 200 dpi itself was very good. So that's about it. And that's how you make 2D plot contour plots, and how to enhance the 2D contour plots in Python. Now with this being done, you can close this file. Okay, you can close this up, and that's how we do it. Now in the next tutorial we'll see how to make plot animations. Okay, thank you guys for watching, and see you guys next time. So take care.